See the painting process that we're using. We've got a two-part epoxy that they're using for the complete white and blue painting of the structure. They're doing the bottom in a dark blue. The upper section is a two-coat white epoxy, and the reason we do the darker colors on the bottom is for maintenance purposes after. With the hockey players and general patrons rubbing against the bottom, it'll be real easy if we ever need to recoat the bottom to do that in a separate color, avoid of painting the whole complex over. The ductwork for the dehumidification system. These are the return grills. Now all of this ductwork will be painted white to blend into the building. We don't want to bring attention to the ductwork. The discharge duct runs across the building and discharges on the other side. You can see they've started to prime the ductwork on that side because that'll be painted white. They need to prime it because it's a galvanized finish. There's not a lot of ductwork that's required for the dehumidifier, as long as the discharge and the suction are at least 40 feet away from each other, and the airflow both coming from and leaving the dehumidifiers in a laminar flow. We don't want a lot of turbidity or velocity in the airstream. We want to try to have the air stagnate over the ice sheet as much as possible and not be turned over by the dehumidification system's discharge air. See here they're starting to put the backing on the dashboards as well. A combination of backed and unbacked dashboards will exist throughout the complex so we can show customers the difference between the two and what the finished appearance is. In the mechanical room, we're going to start the chiller system up. System's been fully installed. We're hooking up and commissioning out. Hey Jack, that looks good on video.
Cool. Good for me, good for you.
There they have the microprocessor system that they're looking to commission out. If I can get a picture of it. Basically, they're going through the commissioning process now. They're doing all the functions that are required to troubleshoot the units so they'll be up and running properly. Ice paint ready for painting the ice sheet. Go outside and take a look at the condenser and the dehumidifier outside. Here you see the vap condenser and the receiver skid, complete with the LPA pumps on the bottom. See here the piping still not painted. We'll be color coding that to match the system. Ventilation for the boiler room, air conditioning, heating units for the office area upstairs, dehumidifier ductwork, dehumidifier vent, gas line coming in. See here the metal skin is still being put on the outside of the building, back on the masonry section of the building. Manufacturing side and the outside staging area, which is actually going to be fully closed in. Just haven't put the sheet metal up yet. in the hallway to the locker room. The ceiling will have a drop ceiling in it. Above the drop ceiling we have more mechanical runs. There's a Picasso at work. How's it going, Leonard?
That's good.
Here's a cutout for the fire extinguisher. We recess now. This will also have a lower layer loop for wear and maintenance. You can see here there's painted the epoxy on the top, and the bottom all they have is a block filler, which is the white sealant allows the paint to fill the block there. Here we are inside the locker room. The ductwork will be painted. It's been primed. Surface mount fixtures with polycarbonate covers, and you can see our forced air heater. And here we have a adjoining gas room. Masonry divider walls for durability, urinals, sinks, and handicap toilet area. On one side, floor drain with rubber flooring will go right over. And then on the other side we have our shower station, which has our three shower heads. That'll be epoxy coated on the bottom of the color as well. Concrete curb for the shower. And also a drain on the bottom of the floor there as well. This side and see the locker room.
Fantastic door prizes. All you need to do is go ahead and take the research part exit of 322 and the front stand of the especially for bridal show 1 to 4.
Okay, over on this side, they're beginning to start putting the rubber flooring. Installing the Nora flooring in the bathroom area.
Number says tape to the FBI, right? Cover my face. Yeah.
The important thing here in getting the flooring in for the toilet room areas is to have the flooring installed before the toilets are in, so we don't have to cut the rubber flooring around the toilets, and the toilets will actually mount onto the rubber flooring. Make it ice. Coming out of the condenser. Here we are, we're in the locker rooms. Putting down some, what is this, latex?
This is epoxy adhesive.
Epoxy adhesive. Okay? Putting down the Nora flooring. Let's see how we trowel this stuff down here, Dennis.
Okay.
Now this has a smooth back instead of a cone back material, right?
Correct.
And this has already been dry fitted in the whole room?
Dry fitted, ready to go. We just pull it up and give 100% coverage.
Okay. Some of the important factors in here, obviously, is having a clean floor, having it dry, not having too much moisture content.
Correct. And also the fact that you don't have much time to spread the adhesive.
Okay, this adhesive, it's a 2-part mixed epoxy.
Correct. It has about a 30-minute pot life, depending on heat and humidity.
Okay.
Factors depend on how much spread time you have.
I see. Okay, now this room's pretty warm. It's about, what, 75 degrees in here, so
Yes.
pot life is pretty critical, I would think.
Yeah. We're certainly within temperature range as far as applying not only the adhesive but also installing
Okay.
the rubber.
Right. Now, all the concrete and the rest of the building here has been put in with a vapor barrier underneath it, so we don't have moisture problems later on underneath the rubber flooring. Also, is there concerns about grease and oil, those type of things on the concrete?
Correct. Yeah. No curing agents, no grease, no paint.
Okay, we said the curing agent, that's an agent that they usually put on concrete to seal the moisture in during curing for the concrete. That's a standard practice for putting concrete floors in, so it's real important to tell the concrete contractor beforehand not to add the curing compound to the top of the concrete slabs.
Correct. And as long as you have a minimum 30-day cure time on your concrete.
And that's to hydrate the moisture out of the concrete.
Correct. And also so that there's no shrinkage of the concrete over the time that it's shrunk the majority
Right.
that it needed to during that point in time.
Super. You know, we're doing in the bathroom areas, and this will allow them, you can see there's the drain for the toilet, to mount the toilet on top of this. Is that a special type of trowel that you use to put the rubber flooring down? Is it a notch trowel?
No, it's just the correct notches for this adhesive. But other than that, it's just a real sturdy, heavy dude. Because as you can see, this stuff doesn't spread very easily.
Yeah, I've seen epoxies go down that are actually almost watery by
It's
comparison.
real stiff, almost like spreading toothpaste, and it makes for a rather slow, difficult type spread.
Dennis from McCaffrey Commercial Flooring was brought in special. He's actually about 2 hours away from this site location because he is a specialist in putting the lower flooring down. They've done this many times before and been highly recommended by the manufacturer. Having a competent flooring installer do your floor with this type of product is very important. It's not like putting a standard carpet or vinyl asbestos or regular VAT tile down. Is the temperature of the rubber itself important, Dennis?
Yes. Again, it has to have a medium temperature. I believe the manufacturer recommends it's 72 degrees or somewhere in that range.
Is there a concern that the rubber itself would expand and contract at different temperatures, or just also a reaction to the epoxy?
As far as I know, it's not a reaction to the epoxy. It's just, again, a matter of exactly that, a matter of the shrinkage that's involved in any kind of material is less than the given working temperature.
Well, one aspect that we found with the rubber flooring with masonry walls, which is pretty typical of an ice rink, is that the concrete work along the edge work be done very neatly and accurately, and this should be conveyed to the masons before they start going hog wild on a building. The reason for that is an awful lot of rinks, we don't put code base around the apex of the flooring to the wall, and in order to get a good quality joint with the rubber flooring, it's best that the concrete's trimmed nice and neat so it's square on the edges, so they can just basically butt the rubber flooring to the wall without having to do an awful lot of trim work or chip work with the concrete. And Dennis is finding out on this job that may not have been told to this contractor as much as it should have been.
Well, again, it can be remedied somewhat by using the epoxy weld, which is basically an epoxy caulk, to fill in those areas where there may be a little more of a gap than what's aesthetically desired.
I see you're doing this in sections. You did a portion of it, and then you came back and did another portion.
Correct.
Is there a reason for that? So
mainly just to keep it, to try to get it back down the same way it was dry fitted, at least as close to that as possible.
Okay. This is the process basically we'll use for the whole building and putting the flooring down, correct?
Correct. Yeah, the larger areas where we don't have as many cut pieces where we're primarily laying full, we may not dry fit, the necessity may not need to be done there. But certainly in this area, it's required.
The rubber flooring has to be installed at a time frame when there's no need for the other contractors to be in the building or be on top of the rubber flooring. There's a period of, how much is it, about 72 hours before they'd like foot traffic on top of it?
Heavy foot traffic.
The heavy foot traffic.
Yeah, 72 hours.
And the reason we don't want foot traffic is every time you're walking on the flooring, it shifts the rubber, and what it'll do is it'll combination break the bond and also open the gaps between the adjoining rubber flooring, and you just won't get the proper finished product. As you can see here, we've got a condition where it's a very small space and they're walking on some of the tile that they've already put down. And what they'll need to do because of that is after the tile's finally pushed in, they'll have to come back and just re-roll all the joints to make sure the joints are nice and tight. And then no foot traffic will be allowed on top of this until it's set for the 72-hour period. The floor is all set in place. What they do is they roll the floor with a heavy weight. You roll it like every 15 minutes or something of that nature?
We try to roll at least 2 to 3 times on each time. Times up to about, definitely in the first hour, we want to get at least one roll on it, and then subsequently at least one more, usually in place. Roll it as diagonal so that you can minimize any movement of the towel.
What we're trying to do is get a good bond between the rubber flooring and the floor itself. And as you'll notice here in this particular area, and I'm zooming in, right now you don't see anything, but underneath there is a drain. And what we do whenever we have a floor drain, the floor drain should be put in flush to the floor. And then after the rubber flooring's down in place, we'll mark where that drain's basically located at, and we come back with a drill bit and a specific hole pattern, and we drill holes right through the rubber flooring with a drill bit to assimilate a drain cover, and that allows any water that's built on top of the rubber flooring to get out to that drain. Is that any special type of roller, Dennis?
It's actually just a sheet vinyl roller. This one's 150 pounds.
That roller weighs 150 pounds?
This one's 100. We like to use 150, which is what we'll use on the main part for.
Okay, I see. You may see that the floor seems like it's depressed a little bit right there. That's where that drain's located at. And of course that's creating a little bit of a challenge putting the flooring down and making it install properly. You can see too, it makes sense to lubricate your roller now and then. It doesn't squeal like a big dog. Your epoxy, when you mix it, do you mix it from the main canisters into a secondary container, or does it all mix into one unit? Okay, so basically inside this unit, for example, we've got a bag, catalyst, and then another resin or something of that nature, so you open it up and mix it all back into that same can. Okay, oh look at that, look at how the top is. Okay, so the top hole is one section of it, and then the bottom of the can is the other material, so it can still come over one can and they mix it together in that same unit. That's pretty cool. Here we are on the sand floor, where it's starting to freeze up. You see all that water basically solidified in the sand. What the fellows are doing now running around the perimeter where there are a little bit of washouts and that sort of thing. Right there, a little bit of a washout during the initial flooding period. Hopefully this will dress up the edges real nice. It'll stand perfectly uniform around the whole perimeter. Conscientious to make sure that the floor is as perfect can be with a sand floor.
Here we're getting ready to paint the ice sheet. Getting all the equipment we need for painting.
Ice cracked, Dad.
Yep, careful.
See that all the ice cracked?
Yep, that's why they're trying to drive the Zamboni out. Move out of the way, son.
Okay.
At this point, the ice sheet's been flooded to a level condition, and it's just prior to the painting process. And what we'll do is we take the ice resurfacing machine out, drive it around, to relieve all the stresses that have been created during the first freezing process. What we want to try to do here is create a condition where the ice will crack before we paint it and settle in, so it doesn't crack after the painting process, which would create an unsightly condition and ruin the paint job. Here you can see the fracture cracks which take place and why we want to have this happen before we paint. If we paint it first, all of those cracks would show up through the paint. You can hear in the background the ice cracking. And this only happens the very first ice building process. Is there a cracking, Jonathan? Okay.
Sounds like wood cracking.
Yep, come on out towards the middle here. Stress cracks that are created. Professional ice tester.
What?
Professional ice tester at work.
You just get one bag at a time there, monster. Here we're getting ready to do the ice painting process.
Here we're just waiting for the ice to finally set up. I'm going to start the ice painting process. You can see the marks that the Zamboni stud tires make. This is a new Zamboni with new studs on it, but they're very aggressive. When you look at the concrete that's out beyond the rink where the Zamboni is going to be driving, you want to get into a higher PSI concrete just for that very one reason. If you put a low PSI, 2,500, even 3,500 PSI concrete right outside the Zamboni door, those studded tires will wear right through the top of the concrete and fall the top of the concrete. All right, another 15-20 minutes, we'll be ready to paint this.
Now we're staging the ice paint in such a fashion that it'll be real easy to keep track of how many drums we put down. Essentially, we'll use 2 bags per 32-gallon container of water that'll be mixed. It's important to mix the paint evenly and consistently through the whole process, not to make it too thick that you run out of paint, or to mix it in different consistencies, which will create light and dark spots on the rink floor. You want to make sure all the lighting's on at the time you start the painting process. You okay, pal? Okay, keep spraying. Get that paint down. That is the first coat. We'll give this many coats after this. It'll be a uniform whiteness. You can see here the glass is fogged a little bit of a fog over the ice sheet. We don't have the dehumidification up and running yet. They have to finish the duct work tomorrow morning. At the time of the year, it's really not a problem for us till it's wintertime. That works pretty good, doesn't it, Brad?
That works great, sir. As soon as you leave, we're going back to 2 hoses and a thumb.
Get out of here. That does a nice even job.
He was digging up something.
Here we're back in the mechanical room. You can see we're past the point of painting. We're actually using the ice sheet now. There's some resurfacing stuff. You can see basically what we did to dress up snow melting pit. The machine's in the way right now to see the actual guide. Obviously, we're still in construction. The walls in the mechanical room are going to be painted in about 2 days from now. But everything's white. The rubber flooring is being installed in the other rooms, which I'll show. Here you can see how the rubber flooring comes in. We want to make sure the rubber flooring is stored in a warm environment before it's installed onto the floor. Same with the epoxy that's used for the floor. Solvent-free urethane adhesive for putting down a Nora flooring system. The material itself that we use for the Nora product, as you can see, it's a very heavy-duty material. We have it with a hammer finish on the other side. and a smooth finish on the back. There's not a cone back on it. See the hammer finish. The reason we go with a hammer finish as opposed to the round little dots that you can also get on these type of flooring is for cleaning purposes. The round dots are literally a nightmare for getting clean. The dirt gathers in between the dots. Over here, we can see into the snow pit. You see where our coils come in. And there's a grid on the bottom of the snow pit for melting the snow. Over here we can see where the lines go into the pit. And the circulating pumps for circulating the water through there for the heated water. Also right next to it we can see the fill line for the Zamboni. And as you'll note, you have a hot water line, a cold water line, and then a common line. So we have a mixing condition. We are missing a thermostat that's still going to be put in here. We're also going to be putting a solenoid valve in with a timer for an automatic fill time. So basically the operator will be able to push a button and fill the machine. We'll show that a little bit later on as well. Over here on the manufacturing side, the floors are completely in. All the electrical is done.